have some inscribed shapes. It says, if the length of AB is x units, what is the area of the center circle? So some important caveats before we start the question. Each of these semicircles are equivalent to each other in terms of area, and each of these semicircles are also exactly half the area of this center circle. Okay, with that in mind, how do we solve the question? Well, the first thing we want to do is write out the area equation for a circle, right? So that is going to be pi r squared. I see in our answer choices that there's nothing really we can manipulate besides define something with the variable x in it. How do we find the radius in terms of x? Well, we can see that we have features, right? We have features of our rectangle as x, one side of it x, and therefore we must find the radius in terms of x. So how do we do that? Well, we do have to get a little creative. So we see here, we can just split the entire shape down the middle. We have split the rectangle down the middle. And what does this do? Well, we can see that now it creates two equivalent semicircles, right? So these semicircles, the area that I've just highlighted, are equal to each other in terms of area. And that's interesting because we just split our original center circle down the middle. And so this is now 1/2, right? Each of these parts of our center circle is 1/2 of the original area. So if we were to add the other half to our new half, 1/2 plus 1/2 is just 1. So this area I've shaded in is the exact same area as that center circle. So what happens to x? Well, we just split the rectangle down the middle, and so x for this portion right here in red is really just 1/2 x. But we're trying to find everything in terms of our radius, right? Because we're trying to put it into the expression, and therefore we just have to look at half of this, right? Because we know that these two parts are equal to each other in terms of area, and therefore we can also just split this down the middle, and we know that this part, let me get green, this part right here will just be the radius. And therefore, how do we find the radius here? Well, we just take 1/2 of 1/2 x. 1/2 of 1/2 x is just 1/4 x, and now we have our radius. And so now we can do pi times our radius, which is 1/4 x squared, and then just some simple rearranging. So 1/4 squared is 1/16, and then x squared is just x squared. So this would be 1x squared multiplied by our pi on top. I'm actually just gonna write pi like this, save myself some characters. And so our area is gonna be pi times x squared over 16. And we can see that matches up with answer choice A, and therefore that is our answer.